Yeah, thank you very much, and thank you very much for this invitation. I'm really honored to be here and give a presentation about science career models. And in fact, why I'm tackling with this topic is that I've been working in several different countries, and in fact also collaborated with quite a few people in the past. And I'm personally really interested in science career models, especially from the perspective of young researchers. And this is an Estonian, but I've addressed this issue already more than 10 years ago, that young people don't have very good career opportunities in Estonian science system, and also try to open up the debate recently. And in fact, why do we need the career models is a really important question. And if we look at from a side of biological age, and it's clear that we all are getting older, and that's clear. And we need to have a way into science from one side, and then also there should be a way out of science. And of course, staying in science is equally important because there are many other opportunities actually. People being in science are really educated people, and they definitely will find a way working and living a nice life outside of the science. And in fact, this is why we need a career model. We need to have a career perspective. So that's really important, especially to attract young people to go into science, because we know it's actually difficult. It's getting more and more difficult with Science 2.0 especially. I guess it's getting very, very difficult in the beginning. And this is maybe not really like a politically correct question addressing the effect of biological age of science, but this is a reality. There are a lot of exceptions, but nevertheless, there is a certain optimal age for scientists. And if you look, there was a nice paper in PNAS actually, which was published recently. It's a PNAS early edition now. And what this figure shows actually, this is actually quite interesting figure in a way, that this is a year of great achievement, and the fraction of scientists achieving this at the age of 30 and the age of 40. And what you see from here is actually, in fact, less and less physicists are making this great achievement at young age. So it's actually, we see this is shifting towards old ages. At least in physics, it requires more teamwork, especially in experimental physics. This is the rules that the achievement is made later. And in the case of biomedicine, it's still actually in a way that even maybe is slightly increasing, that the age of great achievement is made in younger ages. So in fact, it's important, this age management is very important in science. And in fact, I'm already beyond the age, which is unfortunate, but that's a life. And in fact, if we look here, how the things work in French system, it's according to INRA, how it works. There are three activities of the researcher in this triangle. There's research, transfer, organization. And in early careers, research is most important, but depending on the career path, is actually these other areas of transfer of knowledge and organization are becoming very important. And that's also, I learned in Swedish systems that the managers are filling these positions actually, which are very important actually, having this scientific perspective. And this is actually really very important. And being at this stage, managing science and being educating young people is very important at this age. So that's very important to consider, that these activities are shifting in different systems. And if you look at the career models, there is European University Institutes that is providing information on many career models. You can look at this. The information is not necessarily correct, but there are people dealing with different careers. And basically we can divide the career models between faculty versus researchers. Is basically the faculty is assistant, associate, full professors, lecturers, and so on, is engaged in both undergraduate and graduate teaching and in research. It's both activities, but also main activity is very important activity is teaching. And in the case of pure research institution, researchers, there are researchers, senior researchers, scientists are mainly involved in research. And faculty is in universities, researchers are in research institutions. There are several pure research institutions, very important players worldwide. And But what is the general tendency is that there are increasing efforts to facilitate collaboration between universities and pure research institutions. So that is actually worldwide as a general tendency as more strongly to be linked to higher education institutions. If we look at the Estonian systems, and we have a really large number of researchers affiliated to university, and these are historical reasons because when the institutes of academy were merged with universities, and the people went to universities, and this is how it works actually. We have a lot of researchers which are not engaged in teaching at universities. Well, if we start looking at these science models, there are systems with tenure and a non-tenure system. And tenure track is mainly Anglo-American science system. The word tenure comes from the Latin word tenitura, which means possess something, and this means having a permanent position in science. It was first introduced in 1910 in New Jersey. It has concepts are actually deeply rooted in academic freedom, mainly to be able to say something without being afraid of being fired. And in all these systems, its important component is a certain approbation period after which it is decided whether people can stay at the university or has to leave the university. And it really is, it's very important to have it with a certain length. It cannot be endless. Well, and there are also tenured positions at a non-tenure track. I will show you this in a moment. In the United States, the tenure track system, this is the only system I would like to go into more detail. It starts actually mainly from PhD. After getting PhD, one can get assistant professor, and this is a very strong selection filter. Normally when the position is open, there are 100 to 200 applicants per position. And it has to be in different universities under normal circumstances. Then after a certain period, it's a minimum is 3, maximum normally at 5 is evaluation. And after evaluation, if it's negative, then the person has to leave. There is actually no way. Normally the contract is extended for 12 months or 6 months, depending on university. And then there is an opportunity to apply again, but this is already in different university. No way in the same university. When it's positively evaluated in most universities, the position becomes permanent, is promoted, one becomes associate professor, and then this can go further. One can, it's negative, one stays at associate professor level, but it's permanent, it does not have to leave. And when it's positive, it's a full professor, there are different pay grades, and then I made also these paths which are less likely, occur seldom, but one can become a full professor and due chair and so on, so it actually can go further. And there is actually also professors that are not tenured, adjunct professor, research professor, so this is non-tenured part and this is tenured. Tenured means that really it's almost impossible to fire, even in the United States, which is actually like very liberal in a kind of way, very competitive. Now if we go to German systems, then it's tenured but non-tenured track. So which means that basically if one becomes a W true professor, which is here is tenured, here all this position are non-tenured, then one can stay at this level, but there is normally no way to progress within the same university. And this is also called Hausberufungsverbot, which means this is to avoid inbreeding in science. And well, this is a German system. Here is a French system, which is a bit more complicated, and you see here is actually also changes between here is scientific positions, here are positions at universities. This is quite seldom actually, when one moves between charge de recherche and maître de conférence, that's quite seldom. But here at the level of directeur de recherche and the full professor, this can occur actually. And what is actually interesting component in French universities is first of all, the application is national to become postdoc and to become scientist. And on the other hand, in the case of promotions, there is nationwide competition. So if you're a good candidate in Paris, the university in Paris will get the higher ranking position, and that's good for the university. If there is a Clermont-Ferrand will get this position. So it actually depends on which candidates there are. So there are good candidates from one place, the university is getting actually more money centrally located. So that's actually like quite good to some reason. Here's a Swedish system which I considered actually very progressive until I was talking today with Gunnar. Because in Sweden there is tenure track system. But you see, it's also quite many this sort of unlikely changes that occur seldom, depending also whether somebody gets a grant, and if there is a grant, there is a possibility to be promoted. And this makes things untransparent, which is not that good. I constructed this with the help of my postdoc from Sweden. So that's the Swedish system. In the case of Finland, it's non-tenure track system, but civil servants. So there are people who are tenured here, and then there are people who are not tenured. So it's actually like main path who this goes this way. And what is actually the most untransparent in the Finnish systems is the formation of vacancy. Whether there is vacancy is not clear actually. If somebody is assistant professor, it can stay is non-tenured, and there is no way to say, or actually there is maybe a way to say, but it's not very clear, or no expectations when a professor position will open up. And that's actually like a big problem of Finnish system, and is actually, people try to change this actually. There are a lot of scientific correspondence on how they want to modify it really and then make it more transparent. In the case of Estonian system, actually you see a lot of opportunities apparently, but what I must say is actually here in Estonia temporal contracts are prevailing. Is all of these positions are temporal. Even full professor is temporal contract. Unless there is like 3 reviews in a row, it's 5 years position. If it's professor has been appointed on the same position for 11 years, the same university can offer like tenure for the professor, but not a different university. So if you are in one university, you have said, and you can get tenure, but this is actually like a caricature of tenure, because university can fire a professor with tenure saying this 1 month ahead. And in the case of temporal contract, if somebody has 5 years contract, university has to pay for 5 years when the person is fired in the first year. And actually it's much better to be on temporal contracts than having a tenure as university professor. So it's actually like really not a very good system. But another problem here is actually that the people be on lecturer and docent, the so-called associate professor positions are heavily occupied with teaching. And this career path moving from lecturer to docent, it might occur quite frequently. But then from docent to professor, that's unlikely. It's actually more likely the path from researcher. Because the evaluation, like selection of professors is based on research, mainly on research, like everywhere in the world actually. This is not to blame. But it's very difficult actually. And what is actually not really transparent is the vacancy formation. It's actually like very difficult to say when there is a vacancy. And also here, if somebody has a 5 years position, whether the position will be opened up again, there is no guarantee. And here is actually the career movement pathways in Tartu University and the Estonian University of Life Sciences. To cut the long story short, is actually I want to emphasize the point that the majority of high-level faculty are coming outside the career model. It's coming from science, not from faculty. So it's actually like really unfair for young people who start as lecturer or associate professor. It's actually very difficult to make it to high-level position simply because there is no clear career model and there is no guarantee that actually even a professor position will open up in this field. And there is in Europe there is a lot of thinking about how to improve the matters, and here is a number of reports. They say there might be time for tenure track in Europe in science. There was recently a paper, Structure Academic Careers in Europe. And also there was already in year 2000 people wanted to make this era happening, and basically to permit free movement of researchers, scientific knowledge and technology. To make it similar, because there is a mess with careers across Europe. They are very, very different. There are no equal position in different countries. And in fact, the career paths make reaching this goal very difficult, because they are so diverse across Europe. It was not reached by 2010, so it was like now the politicians say 2014 we must make it, but it was already in the agenda by 2010. This was not reached is now in 2020 agenda. And there is a lot of thinking about this. I was actually like, in your slide, it was actually much better picture. And I was wondering why is actually the center in Moscow? So that was actually curious to me, in this place. It should be Moscow, I think. But it's, yeah, well, it's important to be connected, probably. Well, what is the practices towards excellence in most successful labs? And what they say is actually like strategy decision, what to do research actually, but also talent management is an integral component of all of the most successful labs in the world. Portfolio and project management, what project to investigate, to really make a strategy, what to do. Problem solving, collaboration, these are the important things. And talent management is actually not a simple thing. There are many things, and also how, like leadership development, succession planning, learning development, performance management, and so on. So this is actually really important for young people to be in this circle and manage this. Well, another thing why I'm actually addressing this today is actually how this is linked to excellence in research. It's not only age management or like a movement of researchers or transfer of knowledge. It's actually what is really a problem with poor career models is that there are unclear policies for vacancy formation. So which means that actually there is, the vacancies are open, but it's not no guarantees the vacancies are open for the best. It's just opened, and there are so many different fields, and the way it's opened is not transparent. It's just opened, and at the end, it's interesting is Spanish system, where it's also nationwide competition for tenured position, and there are 200 panels, and which are very narrow actually, and which basically means that the openings are dissolving in these 200 panels, and it's no guarantees that, and there might be only one successful candidate for certain panels. Which is a big problem for Spain. Well, another problem is not really transparent policies for employment. Again, what are the selection criteria and non-transparent or non-existing policies for promotion? That's very important actually for young people to understand where the life is going actually, whether there are opportunities for promotion or not. So in some cases there are no opportunities for promotion, and that's actually not a good thing. And why this is not a good thing is that such policies can lead to academic inbreeding, academic nepotism, recruitment of low productive researchers, mediocrity, which means low risk research, and brain drain and sex discrimination. So there is all bad things which are associated with poor career models. I will focus on some of them now one by one. Is academic inbreeding, which is staying home. It's actually much better to stay home. There's no risk, it's just let's stay home. And and this is inbreeding. Basically inbreed faculty is a faculty which has got a degree from the university or institution employing them. So without evidence of postdoctoral mobility. Another term is silver-coded faculty is as inbred, getting the PhD in one institution and working in the same institution, but returning to the institution, being meanwhile outside. So it's actually not really inbred, but it has stronger connection to the same institution. And non-inbred faculty is getting degrees from different institutions. There was a paper about academic inbreeding, and it's very difficult to assess what is the role of inbreeding. And in fact, in this paper, this was one of the really quantitative papers, and here's another one, quite good, just recently published. And what this graph, this was a naval paper, what it shows is that on average, inbred faculty generate 15% less peer reviewed publications and are 40% less likely to exchange information and collaborate with external colleagues. So that's very big problem actually. It's basically staying home means less connections and then lower scientific productivity, which has immediate impacts on excellence in research. So like inbreeding is really bad. And in some systems, actually like in Germany or in the United States, is actually not really perceived from the society as a problem, because this is very seldom, if at all, happening. And in Europe, in many places, this is actually quite common. academic nepotism is even probably a bigger problem, which is very difficult to evaluate what can be the problems with how important it is, but it basically it can be favoring relatives, which is like close relatives, friends, close colleagues, and favoring friends, close colleagues is difficult to evaluate. Hiring relatives is taboo in many science systems, but not everywhere. And close colleagues, hiring close colleagues can be quite common. There was a recent paper about measuring nepotism with shared last names in Italy. And in fact, there is what you see here is a clear north-south gradient. So the darker the color, the more likely nepotism there is. And then actually, here the province of Lazio in central Italy is actually like outlier, but this is Rome actually. So it's the most competitive place to work. It's more difficult to get actually a faculty job. So it's less nepotism. But overall you see this gradient. And this occurs actually. There was recently a paper in Science about nepotism in peer review. That's friends or close colleagues are reviewing papers and so on. So that's actually a big problem. And this is also basically translates into opening of vacancies and selection routines. If these are not rigorous, if these are not transparent, this is a big problem actually. At sense, it also reduces the productivity in faculties. Another important problem is actually stop-and-go policies. And I consider this even maybe most devastating out of all problems. Which means that random opening of vacancies or lack of clear promotion policies. Here's an example of a paper, working paper published by Italian and French colleagues about scientific productivity and academic promotion in France and Italy. Here in France was actually was a long period of almost no openings in science until year 1985, when they opened a lot of positions in one go. And then there was a more or less even opening of position until again 2004, where actually government shut off all openings. And especially this was a devastating period. So there was no ways of young people to enter science. And the situation was very similar in Italy actually. It's 1980 when they opened, like you see, it's almost like 0 positions opened. Here is 10 positions opened, and in one go, like almost 400 positions became available. And they investigated the role of these kind of years when there was a lot of positions opening on the scientific productivity of those people staying in science like years later. And in fact, it turned out that in these years when there was this inflation, a lot of positions became open was inflation of productivity of scientists. In fact, these researchers hired here, of course there were many excellent people, but overall the productivity was very moderate compared with people entered in these years when it was more difficult to get a job. And in fact, it's also a problem because now they opened and then it was 2, 3, 4 years when there was no opening again. And these people we see later actually, they don't stay in Italy actually. So it's actually a big problem for Italy in terms of brain drain, having these sort of policies, which means that government is actually not having really long-term planning, but is opening 1 year and then not opening another year. So that's very bad. And in fact, there was a paper in Nature Physics analyzing the age structure of Italian physicists, and what they say here is reverse age discrimination. Age discrimination is basically used to be in faculty systems that like if somebody was getting 65, for instance, then it has to leave the university. It's called age discrimination. But reverse age discrimination means that there is no opportunities for young people to enter science. And you see here, below 30 class or below 40 class, here is only less than 4% physicists are there in Italy, and then there is more than 60, is more than 40%. So it's actually like this sort of, they call it reverse age discrimination. And if you compare the similar thing in the United States, in fact this is curious because in the United States it used to be compulsory age of retirement until 1994. And it was abolished, and then people were afraid that things older faculty will become more dominant, but in fact this did not happen. And it's there are several reasons which are not actually yet quite clear, but in fact is similar, and you see it's around 5% is like a share of all the faculty compared with physicists in Italy, which is more than 40. That's, now if we look at the Estonian system, this is an analysis I made, and it's based on the national target funded project. Is actually like a major source of funding for research teams, and then these people leading the teams, there has been altogether 472 team leaders over the full period of funding of 1998 to 2013. So it's actually like, from an Estonian point of view, they are considered the best of the best, actually, like really leading the research teams. What you see here is actually, like if we look at the young team leaders, that it's actually fluctuating. It's actually the case is very similar like in Italy. And if one tries to explain this fluctuations, and there were 2 years, in 2003 and 2004, where there was a major increase in funding. In fact, in 2008, the funding increase was 30% in one go, 1 year. And then this was actually the year when there was an opportunity for young team leaders. And young is considered in this context below 40 years old. So it was actually the way to get into the system. And then I didn't realize that I was really lucky, but this was where I entered actually in the system. So it was 2003. So it was actually also the golden year. But then look what happened after. And that's actually very bad. This was like a reduction in funding due to economic recession. And in fact, like 1-2 positions, like young team leaders entering into the system. It's actually like after this peak year was basically followed by 5 years of really bad years without any ways of young people to enter into the system. And this is also actually mirrored with average age of the team leaders. What you see here is increasing, and then it's like opportunity to enter, and then it's decreasing, and again this is changing, increasing again. But if we look at from like a share, like it's basically there's a share of young team leaders and share of over 65 team leaders. What you see here is basically these years where the funding period is 5 years when most of this target funded project finished. This was a year where there was an opportunity for young people to enter into the system. It's basically, and then between these years, the average age was increasing all the time. And it was actually stabilizing at higher and higher level. And the prediction is, if this trend is continuing, in 5 years' time, we will have more than 30% of team leaders over 65 years old. Another trend was until year 2008, the share of young team leaders was increasing. It's actually like accumulative. Yeah? There were some young team leaders were 32, and then by the time of like 5-6 years later, they were still below 40, so this was increasing until this kind of breaking point here. And then this is a magic breaking point. I was looking what can be the reason, and in fact I think the reason is abolishment of compulsory age of retirement. That's actually hit, and we are now in year 2013, we are back in 1998. This is actually like a really bad tendency, Estonian funding system, which is associated with all these changes in economy, and then there are like really obligatory reasons. But on the other hand, it also reflects that we are really not taking care of career management and generating these opportunities. It's not really like providing some handicap, but really that tendency is quite worrisome. The other issue is playing too safe, and like the problem in nowadays science funding is really that one has to perform, and the performance, if there are only single criteria based on publishing the number of papers and all those things, then it's actually safer. It's better to play safe. It follows the line of research which is easy to publish. And in grant-based science research systems, this is a problem, and this has been addressed recently. For instance, there was one commentary in Science Chronicle that we must stop the avalanche of low-quality research. If we look at the Nobel Prize winners, here is Wolfgang Ketterle, who got the Nobel Prize in Physics in 2001. There are people actually writing papers, scientometric papers, what somebody else has been doing, and these are, by the way, actually very well cited papers. So, people are interested what people have done during their career, and this guy was getting the Nobel Prize on the work on Bose-Einstein condensation, which he started just in here, and already in 5 years' time, he was getting a Nobel Prize on this work. And in fact, if you look, this is a cumulative number of citations in different science domains. And I think, in these days it's presented in a way to avoid embarrassment, because if you look, if this stays flat, it means 0 publications. And in fact, these people were working very hard, but they were working at something different, and being only in grant-based society, this would be impossible. It's impossible, because if you don't publish, you are gone, you are out of the system. And in fact, it can be counterproductive to work only for grants and not having the opportunity to productively change field. It takes time. It always is a lag phase until one gets published in a different field. Here's another example of Nobel Prize in Medicine winner Leland Hartwell, and it's a very similar thing, what you see here. It's basically in some fields you see the lines stay flat. And there is another line of research starting, but in the beginning it's very slowly. It's maybe 1 publication per year, 2, and then under normal circumstances we would consider in nowadays world is non-productive. Out. We don't fund that because it's not producing. But in fact, one needs to have this kind of career security to be there and be able to work and find out something new. So, in fact, this sort of publish or perish policies can be really devastating in some fields, really in the world of scientific excellence. And another thing is career models and brain drains, and there is a lot of opportunities out there for young people in these days. There's Canada, there's France, there's the United States, there's Spain. There are a lot of opportunities, and here is, people have addressed especially Italian brain drain, because there is a lot of people leaving Italy. Partly also because of the low salaries, as it was mentioned, because it's really, Estonian salaries are becoming closer to Italian ones. And here's another example of Italian brain drain. This actually is a benefit of United Kingdom, actually. So people are doing research there. And if you compare OECD migrant populations, Germany is the biggest winner, France, Spain, Britain, but you see Italy is actually losing brains. And here's a recent analysis of mobility among European Union countries who have responded. It's not all countries. And you see that Germany, France, Great Britain, Sweden, they are gaining brains, and many countries like Spain, due to recession, Greece in particular, but also Estonia slightly, are losing brains. And this is something which is we need to think about, because the mobility of researchers, is it a good thing or is it a bad thing? In fact, you don't need to travel to collaborate with somebody. These people who have left are basically, they might return, but it's not really mobility due to career opportunities. It's actually for career opportunities. If there are no career opportunities, one is moving, and that's actually something we need also to consider. And that's all I wanted to say. Thank you.